The overall goal of this procedure is to fabricate freely suspended micron to sub-micron scale polymer fibers and web-like structures using an automated direct writing procedure by means of a 3-axis dispensing system. This is accomplished by first setting up the automated equipment with the valve controller and dispensing system. After the mechanical setup, the liquid polymer sources are synthesized and quality control is assessed by assaying for rheological parameters such as surface tension and viscosity. Next, the structures are designed using a CAD software. Then, the spatial coordinates of the designed structures are transferred to the robotic controller software. Subsequently, the robot will translate the dispensing needle to the predetermined locations to fabricate freely suspended micron sub-micron scale polymer fibers and web-like designs.
The primary advantage of this technique over others such as wet, dry, and electrospinning is that we can precisely control the fiber diameter and the fiber orientation and dimension in all 3 spatial dimensions.
Generally, individuals new to this technology will struggle because the synergy between surface tension, viscosity, evaporation rate, and feed rate will be okay to successfully producing the fibers over a specified range of diameters.
Demonstrating the procedure today will be Hanwen Yuan, a graduate student in my laboratory.